Right, this lesson is going to focus on something called a normal derivative, and it's just kind of vocab to talk about actually more the physics of derivatives. So where would we ever use derivatives? And if you kind of look down here, we're going to be talking about the height of something, or when does it reach a maximum height, or what is its velocity as it's moving. And so now we're kind of taking the stuff that we know about derivatives and we're going to apply it to almost real world problems. We kind of made these up. So you have a couple of different functions here. The first one is just the one you start with, just a basic function, and this would be called just your height function. So this would tell us how high something is or when it's at a particular height, and that you're quite familiar with because that's just a parabola, and it happens to be upside down. So there's definitely going to be a shape to it where the object that's being, in this case, a monkey is being thrown, which is very anti-PETA. But this monkey is being thrown, and at some point it has a particular height, and then it has to come back down and meet the ground again. So then we have a first derivative, which is velocity. And when you take the first derivative, you're able to plug some numbers in, like a time. You can decide, at 3 seconds, what is the velocity of the monkey. When you have a second derivative, that is talking about your acceleration. So how fast or how quickly something is speeding up or slowing down. So let's use it in context of a problem. So we have the first one, which is just a monkey is thrown upward. So its height is matching this equation, which is the same one from up above. And so it says, what is the height of the monkey at 2 seconds? So what they're asking you to do is just plug in a 2. At 2 seconds, when time is 2, when t, time is 2, what is the height of the monkey? So plugging all of that in and then just reaching for your calculator, you're going to get 19 feet. And we just talked about how this is an upside down parabola, so it's got some shape to it like that. And we're just saying at 2 seconds, wherever that is, how high is the monkey? I made that graph up, so it probably won't match as we go along here, but the next one is, when does the monkey reach its maximum height? Now this is more of a time question. When does that actually happen? So the maximum height would happen right at the top of that parabola, which is also called the axis of symmetry. And if you remember way back, you can find that by doing negative b over 2a. So I'm going to do the same thing here and do negative b over 2a. And reaching for my calculator, typing all that in, I end up with 1.25 seconds. So it takes 1.25 seconds for the monkey to reach its maximum height. What is the maximum height? So at that 1.25 seconds, what is the height of the monkey? And this is just, again, we're just plugging it in. We're just trying to find time. Nope, sorry. We're trying to, if I tell you the time, we're trying to find the height. So put 1.25 there. 1.25 there. Everywhere there's a t, we're putting 1.25 because that's how many seconds we knew it would take for him to reach his maximum height. And pick up your calculator there, and you're going to end up with 28 feet. So the maximum height, the height of the parabola, is 28 feet. Find the velocity of the monkey now. So velocity, looking up above, has to do with the first derivative. So let's find the first derivative. So using my function, I'm just going to pull the 2 in front, so negative 32. T to the first power now, and then plus 40. And I didn't give you a number, so all you can give me back is an equation. So this would work for the velocity of the monkey at any time. You just have to give me a time. And so number 5, it says, what is the velocity of the monkey at 1 second? So we're going to plug a 1 in to the derivative. Velocity goes with first derivative. If I'm giving you a number, then you should be able to plug a number in and find the derivative, or find the velocity. And this would be 8. And in this instance, we're doing feet per second. That's how quickly it's going. Kind of think of that as like your miles per hour. That's your speed. That's your velocity. That's how fast you're traveling. Next up is find the acceleration. So now we want to know what it's doing at any particular time, how quickly it is either increasing or decreasing its speed. Acceleration has to do with the second derivative. So just taking your first derivative and doing it again. So there's a 1 up there. So bring the 1 in front, you'd have negative 32. And it would be t to the 0, so I don't really need the t. And the derivative of 40 is 0. So acceleration is negative 32. Then it says, what's the acceleration of the monkey at 1 second? Since there's nothing to plug into, it would be negative 32 feet per second squared. And if you're familiar with physics, this is the same as the acceleration due to gravity. The normal line, a normal line is perpendicular to the tangent. And we've talked in a previous lesson about how to find the equation of the tangent line to a graph. And so now we're talking about the normal line, one that is perpendicular to that. So I'm going to make this graph up. It's a cube, so it looks something like this. And they're talking to me about x equals 2. So let's just say that that's right about there. So this line right here is the tangent line. What we are talking about finding is this one right here, which is the normal line. And it is used in physics quite a bit in order for you to cancel out a particular force. So if you know how quickly this tangent line is traveling and you need something to counteract it, essentially you're going to find the normal line, which is the one that's perpendicular to it. So what is the equation of a normal line to this graph? So first we need to find the slope of the tangent line at that place. We know that perpendicular lines have opposite reciprocal slope. So if I could find the slope of the tangent one, I could just flip it and that would be my normal. So first we're just talking about my tangent line, and I want to find its slope. So in order to do slope, I got to do derivative. So my first derivative is 3x squared plus 4x, and then remember the derivative of 1 is 0. And we're talking about at 2, so then we need to plug in a 2. We've got to find the slope that happens right at 2. 2 squared plus 4 times 2, which gives me a 20. So the slope of my line is 20. So that means up 20 over 1, up 20 over 1. Real steep line. And that is my slope of the tangent line. The slope of my normal line then, since we're doing perpendicular, will be negative 1/20. All I have to do is flip that and then add a negative to it, and I end up with my slope of the normal line. So in order to find the equation for the normal line, like a y equals mx plus b, I know my m, and we just need to find the b. So I'm going to take my slope and I'm going to plug it in. So I've got negative 1/20. My x is 2. We know that because that's what we're talking about. I'm trying to solve for b, and now I just need a y for this to work out. So if I were to take 2 and plug it into my original equation, I could find the y that goes with that x. So over 2 up how many? That's what I'm trying to figure out. So plug a 2 in. There's a lot of steps to this problem, and you get 17. So that's the point that we're going to use. 217 is the point. They told me the over 2, I plugged it in, I found out that it was 17. So that's the point I'm using, 217. 2 goes there, 17 goes there, and my new slope, my perpendicular slope, my 1/20th slope. And when you do all that, you end up with 17 1/10. Or if you plug it in, you can just have a decimal there for your calculator. Normal derivatives have to do finding more derivatives. So first derivative is velocity, second derivative is acceleration, and using those values as you kind of work along here. 1 through 3 are really old school. Height of a monkey, you're just plugging in a value. When is negative b over 2a, we've done that before. And max height, you're just plugging in your when to figure out how high it is. The rest are then talking about your new derivatives. So velocity had to do with your second, acceleration had to do with your, velocity had to do with your first derivative, acceleration had to do with your second. Normal lines are just perpendicular lines. So first you got to find the slope of your tangent, flip it for your normal, and then plug in your x and y in order to find your y-intercept. The next example says for what points x and y does this have a horizontal tangent line? So we're asking for a tangent line, which means I need derivative right off the bat. And it says it wants it to be horizontal. And if you remember, any line that is horizontal has a slope of 0. So that means I'm just taking this and I'm going to set it equal to 0 and solve for x. So I'm going to take 3x out. So just kind of dividing both of those by 3x, writing what's left, and then I take each of these and set them equal to 0. So 3x equals 0, and then x plus 2 equals 0. So on this side I get 0, on this side I get negative 2. So what we've got so far are the x's. Now I need to find the y's that go with them. So 0, comma, and then negative 2, comma, and we need to find the y's. So what you're going to do is you take, since you're looking for a point that works on this function, you're going to take 0, plug it in up here. So 0 cubed is 0, plus 3 times 0 is 0, minus 1. That's the first point. Second point, I'm going to take negative 2 and plug it in. And I'm going to end up with, I believe, 3. So horizontal tangent line means slope is 0. Find the derivative because you're talking about your tangent. So find the derivative, set them equal to 0, and then solve for x and y. Or solve for x and then plug it in to find your y. One more example of what's the equation of a normal line to the graph. So first we need to find the derivative, which is 6x. That's a nice easy one. Plugging in my negative 1, I get negative 6 for my slope of my tangent line. So my normal line will be the flip of that and positive. So the normal line will be 1/6. So looking to write my overall equation, this is what we're looking at. I just need a plus b over here. So my point I have so far is -1. I need to find the match that goes with -1. So plugging -1 in, I square it, I get 1. Times 3 is 3, minus 1 is 2. So I'm going to go 2 equals 1/6 times -1 plus b. And now we're just trying to figure out what b is. So this would be -6th, add it over, I get 2 1/6. And that is the equation for my normal line. Just finding slope of your tangent, plugging in your point to find your slope, and then flip that guy in order to make it the normal.